name is Mike, and I'm going to go over GelElectrophoresis. GelElectrophoresis uses agarose gel to separate DNA when you load it into the well by its size component. The larger the DNA is, the more resistance it will experience as it travels through the agarose gel. And DNA, because of its phosphate backbone, has a negative charge. So therefore, when hooked up in a GelElectrophoresis chamber, which has a negative and positive charge on both sides, it will move towards the positive side, because opposites attract. So now we're going to go over loading the well. You want to take a micropipette, probably a P20, and take a small amount of DNA sample, which will be dyed blue, so it's visible. Go to the first stop, release. And wells are little indentations in the agarose gel where you can put your DNA sample. Submerge it, but don't cut through the gel. You want to push the second stop once your pipette is inside the well, and push down all the way to the second stop, and your DNA will stay inside the well and not go in any of the other wells. You have your loaded well. And you want to make sure that you stay within the well so it doesn't leak out into the rest of the solution. So after you've loaded your wells, you're going to want to hook up your wires to these points where your electricity will flow through. And to do that, you just slide on the cap, which has a positive and negative wire. And you want the positive wire to be on the opposite side of the gel wells, so the DNA will flow towards the positive side, which is represented by the black wire. Alright, so now you're going to plug in your positive and negative wires into a power source matched up with the positive and negative outputs of the power source. And after about 30 minutes, you can look at your gel and you can see how far the DNA traveled. The DNA will separate based on the size of its fragments, and you can observe the results by looking at your gel.